Hello students, welcome to Laboratory D2. This is parallel capacitors. This laboratory is going to be a parallel configuration of capacitors only. In this particular circuit, if you look at page 78 where the laboratory begins, you'll be able to see that our start of our lab is very similar to the one we had previously. We're using the same value components there, and we're trying to figure out x of c by using the 1 over 2 pi f of c formula to figure out what x of c is. So it's going to be very similar to what we did last time. As you'll see, is that these are the equations that we used, and we just used the equation which was 1 over 2 pi, or 1 over 2 pi times the frequency times capacitance is equal to my x of c. So again, we're setting our frequency at 60 hertz, and we're using the three different valued capacitors, which is 0.33 microfarad, 0.47 microfarad, and 1 microfarad. So you'll do the calculations similar to what you did in the previous lab, and can use those same values in that on the first page in those two tables. Then once we get done with that portion of the lab, we are going to measure voltages and total current and do some computations. Now these are capacitors in parallel. When capacitors are in parallel, we simply add them up. In other words, your total capacitance is C1 plus C2 plus C3. And then for your laboratory, what we will need to do is you're going to read through the instructions just to make sure I didn't miss anything. You're going to measure the voltage on capacitor 1, voltage on capacitor 2, voltage on capacitor 3, and then also you're going to measure total current. And then once you have this information, you're going to calculate your individual branch currents by using Ohm's law. And branch current is going to be equal to the voltage across that capacitor divided by the x of c, or the ohms of that capacitor. And then we can calculate the total impedance, the ZT, the total impedance of this circuit, by taking the total applied voltage divided by the total current read. Once we've done all that, we're going to do some computations using Watt's law, where power is equal to voltage times current, and we're going to calculate each one of those volt-amp reactances in the capacitor. So follow along in the laboratory, make sure you fill all those tables out, and then once you fill those table out, there will be some questions on page 77 you'll need to go through. Make sure you understand all this information before you leave your laboratory, and your lab instructor will be able to help you out and answer any questions you might have. I'll see you in lab.